In this video, we will look at different types of wind turbines. These are all the wind turbines we will discuss in this video. Although I've divided them in different sections, there is no hard and fast rule of how these wind turbines are grouped. You just need to know what these different types are. First, let's have a look at the gear wind turbine and the direct drive wind turbine. So in the gear wind turbine, the rotor, which is here, is directly connected to a gearbox. This is the gearbox, and then it is connected to a generator. So let's say that this rotor is rotating at 10 rpm. This gearbox will increase this rotational speed up to 1000 to 1200 rpm, and this is the same speed at which your generator will be rotating. On the other hand, in the direct drive wind turbine, rotor is directly connected to the generator. So here you can see this is the rotor and this is directly connected to the generator. In this type of configuration, you do not need a gearbox. Next is upwind versus downwind turbine. So in the upwind turbine, the rotor blades are directly facing the wind. So let's say this is the direction of the wind. The rotor blades are directly facing in front of the wind. In this configuration, wind will hit the rotor blades first and then the tower. So this is your tower. These are your blades. Now looking at the downwind configuration, rotor blades are facing away from the wind direction, which is given in red here. And in this configuration, you can see that wind will hit the tower first and then the rotor blades. So this is your tower. Or you can also say that wind will hit the nacelle first, which here is your nacelle. Next configuration is two-bladed wind turbine. So before discussing two-bladed rotors, I just want to mention that most wind turbines are with three-bladed rotors, and this is a long discussion why they are three-bladed. You can watch the video, link is given in the description. So coming back to this, some wind turbines also have two blades. They have very complex dynamics and they are very noisy, and the reason for being noisy is the high tip speed. By tip speed, I mean the speed at which this blade tip is rotating. So they are noisy because your noise is directly proportional to V tip raised to power 5. So as you can see that as the tip speed increases, noise increases by a power of 5. So these type of wind turbines are not yet a commercial success because of the reasons mentioned above. As vertical and horizontal axis wind turbine. So in vertical axis wind turbines, your rotor blades are rotating about a vertical axis. So in this figure, number 1 and number 3 are two different types of vertical axis wind turbine, and you can see that they are rotating about a vertical axis. In a horizontal axis wind turbine, the wind turbine blades rotate about a horizontal axis. So there is one advantage of vertical axis wind turbine is that you do not need to yaw these wind turbines. By yawing, we mean that face the wind turbine in the direction of the wind. So let's say if wind is blowing from here, you will have to change the direction of wind turbine such that the rotor blades face the wind. One disadvantage of vertical axis wind turbine is that they have complex dynamics, which reduces their efficiency. And we have fixed speed versus variable speed wind turbines. In fixed speed wind turbines, rotor blades rotate at constant speed, so generator will also operate at constant speed no matter what the wind speed is. Second point is that generator is directly connected to the grid. And why is that? It's because generator's rotational speed influences its frequency, and constant speed of generator means that output frequency will be constant. And in grids, we need to have all the devices operating at the same frequencies. So constant speed means constant frequency, therefore the generator can be directly connected to the grid. Fixed speed wind turbines are also less efficient, and the reason is that because they don't care about the wind conditions. No matter what the wind conditions is, they will always be rotating at the fixed speed. On the other hand, we have variable speed wind turbines that operate at varying rotational speed, and this is according to changes in the wind conditions. So it means that higher wind conditions you have more speed, lower wind condition low speed. In this situation, we cannot connect the generator directly to the power grid because generator is also rotating at variable speed and you have frequency fluctuations. So we need power electronics converters. These type of wind turbines will have higher costs due to the additional electronics. Next, we have onshore and offshore wind turbines. Onshore wind turbines are installed on land here onshore, and the offshore wind turbines are installed in water bodies such as oceans, seas, and lakes. One advantage of offshore wind turbine is that wind conditions offshore are better, but you also need higher maintenance and construction costs if you want to go offshore. In the end, I would just like to mention that today's most modern wind turbines are horizontal axis, three-bladed, upwind, variable speed wind turbines. This is the configuration that is most efficient. Thank you for watching.